Hi class, how's it going? This is Group 6 Tech Update. My name is Tyler Nimmo. Also in our group is Daniel Doty, Jason Jasper, Patricia Payton, and Drewer Wang. Our group will be presenting on blockchain technology. The previous presentation by Group 5 covered cryptocurrency, and so we wanted to cover the specifics of blockchain technology. We picked this topic because many have heard about blockchain, but how it works might not be fully understood. Just a quick disclaimer our group wanted to throw out there. Our group wanted to say that we're not advocating for or against buying, selling, trading, or using Bitcoin or any other cryptocurrencies. Our purpose is just to try to explain how Bitcoin and, more importantly, how blockchain functions. Um, Below is just a quick outline of our agenda for our presentation. We will be covering just an overview of blockchain, blockchain's advantages and disadvantages, blockchain and Bitcoin wallet, specifically how blockchain works, blockchain's verification process, blockchain industry-specific uses, and some questions for the class. So this is just a brief history of blockchain. In 1991, a cryptographically secured chain of blocks is described for the first time. In 1998, computer scientists attempts to pioneer BitGold, a decentralized digital currency. In 2000, a theory was published regarding cryptographic secured chains and ideas for implementation. In 2008, a developer working under the name Satoshi Nakamoto established the model for a blockchain. And then in 2009, Nakamoto implements the first blockchain as the public ledger for transactions made using Bitcoin. Then in 2014, blockchain is separated from the currency and its potential for other financial and inter-organizational transactions is explored. And then in 2015, Ethereum blockchain is created. So who specifically invented Bitcoin and blockchain? Nobody really knows. The inventor goes under the pseudonym Satoshi Nakamoto, as we mentioned in the previous slide. So most might be familiar with the use of blockchain and cryptocurrency. Cryptocurrency is a medium of exchange created and stored electronically in blockchain and using a encryption technique to control the creation of monetary units and verify the transfer of the funds. And for everyone, Bitcoin is probably the best example of this. The advantages and disadvantages of blockchain will be discussed next by Daniel, so I will hand it off. Thank you.
Thank you, Tyler. Good afternoon, everyone. I'm Daniel Doty with Group 6, and we're discussing blockchain. The advantages of blockchain. Blockchain is a form of coding technology that uses cryptography to secure digital transaction information recorded in a package known as a block. Current technology provides several levels of encryption for different purposes. The encryption most commonly used for blockchain is Secure Hash Algorithm 256. SHA is a coded instruction which scrambles 256 ones or zeros according to the analysis of text or other media being protected. Although there are others, including 224, 384, or 512 bits, the 256-bit algorithm is widely used. There are many much larger digital secure hashes used as well. Computing technology improvements promote the use of better hash algorithms. Some blockchain disadvantages: no matter how secure digital technology is, there exists a community that will work with equal or better technology to disrupt it for many reasons. Blockchain technology has many profit-driven third-party brokerage companies offering investment handling opportunities for Bitcoin and other digital currencies. These third-party brokerages are often hacked by organized alternative groups who sometimes fight for currency freedom without fees and without taxation that is typically leveraged on fiat currency. There are many major incidents of blockchain hacking with severe monetary losses. September 24th, 2021, the People's Republic of China has declared all cryptocurrency transactions illegal. Bad actors and cryptocurrency hacks. The myth of immutability, as discussed by Gideon Greenspan, June 22nd, 2016. In an article, Ethereum was hacked by a coder who discovered that the ledger was not immediately updated after a fund's withdrawal. The coder was able to trigger the fund's withdrawal multiple times in an action called recursion, eventually stealing $50 million worth of funds from stakeholders. The code in the Ethereum blockchain, DAO smart contract, had to be changed by a vote to prevent the same thing from happening again. After the code in the Ethereum smart contract was changed, most of the crypto funds were recovered. Some key points for blockchain and Bitcoin. Bitcoin's blockchain and network are extremely secure and have protected a growing volume of wealth for over 12 years. Bitcoin is the only monetary system which has verifiably never allowed counterfeit currency to circulate. Forensics known as Chainalysis tools are used to track blockchain crimes. The Bitcoin blockchain is not hacked, but third-party profit-seeking brokers are, because they do not secure their networks adequately. Bitcoin was devised as a way to reward those who maintain the blockchain. Here we can see how many different types of digital currencies there are. There's a proliferation of digital currencies. What is a Bitcoin wallet? A Bitcoin wallet is a digital wallet that can hold Bitcoin and other digital currencies. It uses a unique key for security. Anyone who knows the key can access it. It is essentially a public and private cryptographic key pair. Bitcoin wallet is a device or a program that can interact with the Bitcoin blockchain. Bitcoin wallet actually represents cryptographic control of a blockchain address. The types of wallets are mobile, on your smartphone, desktop, on your home computer, on the web, hardware, on an external drive, which is most secure because it can be unplugged from the network, avoiding any kind of a hack. And then the paper wallet will typically be printed as a QR code, and this one is also called cold storage. The example of a Bitcoin wallet here is represented by two separate QR codes. The one on the left is the public code. The one on the right is the secret code that should not be shared. However, in this case, this Bitcoin wallet is now compromised and is no longer secure. The secret code is here and it's shared. So since this wallet is now compromised, there's no reason to access it.
All right, thank you very much, Daniel. Now I'm going to go over some of the more technical aspects of blockchain. This in particular applies to a proof of work type of blockchain, and this has been simplified. There's a lot of caveats that I won't go through for this presentation, but it should get the general idea of how a block is formed for the blockchain. Now, one of the major components of this type of blockchain is cryptographic hashing, specifically SHA-256 hashing. Now, the SHA-256 has four key components that are used to create blocks, and some of these components are that SHA-256 is deterministic, basically meaning inputting the same data gets you the same exact hash every time. It's different hashes for different types of input. Even small changes in the input will output very different hashes. Also, fixed length. No matter how much data or how little data you give to the function, it will output the same length of data, or the same length of hash. In this case, 256 bits, which you'll see I represent in 64 hexadecimal characters. Also, hashing is one way, meaning that once the data is hashed, you cannot figure out what the data was to create that hash. So I'm going to go ahead and show you the deterministic part of this algorithm. As you can see, I inputted the string high, or the data high, and this is the actual hash that you'll get out of it. And if I input that same string into the function, you will get the same exact hash out of it, as you can see here. Even small changes of the input data will create a very different hash. As you can see, all I did here was add an exclamation mark, and it created a completely different hash, which is very important. The next thing is it is a fixed length. If I put in the two letters high, I get the same length of hash as if I fed the algorithm the entire Library of Congress. You're going to get the same 64 hexadecimal characters or 256-bit data out of it. Also, once the data is hashed, you cannot go back and find out what the original data is, or the pre-image as it's called. So that's very important for this particular algorithm. So how's a block formed? First of all, the network, a miner, will listen for transactions. Transactions are transmitted onto the network, and a miner will collect these transactions. And in this case, I've shown 4 transactions. In reality, they would probably take in at least 1,000. It's usually 1,000 to 1,500 transactions before they start building a block. So these are the 4 transactions. And what they'll do next is create what's called a Merkle root using a Merkle tree method. So each of the individual transactions gets its own individual hash. And once that's done, then pairwise they start hashing those hashes together. So you see here hash 0 and hash 1 get hashed together to create hash 0 plus 1. Hash 2 and hash 3 get hashed together to create hash 2 plus 3. And this goes all the way up until you get the final hash. So hash 0 plus 1 gets hashed with hash 2 plus 3, and you get the final hash, or the Merkle root. And this just kind of cryptographically binds all the transactions together. So once you have that, it's time to construct the block. So the block consists of the hash of the previous block, a timestamp, the time that the block was formed, a nonce, which we'll discuss in a few minutes, the Merkle root that was generated in the last step, and then just the list of transactions that were collected from step 1. So once that's all completed, next we need to talk about difficulty. So the difficulty is where things get really interesting. So it's mathematically calculated, and it's recalculated every 2016 blocks, which should equate to roughly every 2 weeks. So the idea of the difficulty is to make it to where a new block is added to the blockchain around, on average, about 10 minutes. And the creator or creators wanted the difficulty recalculated automatically about every 2 weeks. So where does this 2016 number come from? Well, if you take 10 minutes per block, that's 6 new blocks per hour times 24 hours times 14 days or 2 weeks, and that's 2016. Nobody really knows why this number was chosen, but it's theorized that they assume the creator wanted to make sure that blocks weren't being added too quickly or taking too long to be added to the blockchain. Now, if more than 2016 blocks are added in 2 weeks, the difficulty will go up. And if less than 2016 blocks are added to the blockchain in 2 weeks, the difficulty will go down. So it's the difficulty is also called a target. right now the current the difficulty is this long string of, again, hexadecimal numbers you see here. Now, just to make things simple, the best kind of way to think of it is that the target is the number of zeros on the left side of this long string of characters. It's a little bit more complicated than that, but that's a really easy way to think about it. So in this case, it's 19 zeros. So what they're trying to do is guess the nonce. So a nonce is something that you add to hashes. It's usually random data, more random data, to make the hashes even more random. And it stands for number used once, nonce. So what miners are trying to do when they're doing all these calculations, they're trying to find a nonce, or a random set of numbers that when they add it to the block and they hash it, it creates the most amount of zeros, as I showed you earlier. And the first Bitcoin miner that submits a validated block gets the reward, Bitcoin in this case. There's other cryptocurrencies that use the blockchain, but once this new block has been added, everyone has to start over because they have to use the hash from the previous block to create their own block. And this is an example of an actual hash that was solved. Bitcoin block 33,000, which was actually kind of a long time ago. And as you can see here, the difficulty back then was actually a little bit higher, so it had to be reduced somewhat. But you see the highlighted set of zeros. That is what they want to see. And once they generate the same amount or more zeros, then they transmit that block back to the blockchain network, and then it goes through the validation process. So the validation process is something that Patricia is going to talk about now.
Thank you, Jason. I am now going to talk about the blockchain verification process. Within the blockchain network, when a new block is submitted, validators check to make sure that no transaction in your block has already been added to the blockchain. If there's anything invalid within a block, it is rejected and not added. If more than 50% of the network agrees that the block is valid, it is then added to the blockchain and an award is given to the miner. Taking a deeper look, this mechanism is called proof of work, and it's used for some public blockchains, meaning that anyone can participate. It requires that members of the network provide evidence that they have expended computational power to achieve a consensus. This prevents bad actors from overtaking the network. This mechanism is used in cryptocurrency mining for verifying transactions and mining new coins. However, it's considered very wasteful because this technique requires a lot of energy. Because proof of work uses so much energy, proof of stake was developed as an alternative that is more sustainable. With this model, a person uses their tokens as collateral to mine or validate block transactions, and their mining power is determined by the proportion of coins that they hold. If someone submits an invalid block, they'll lose the money that they used as collateral. This model discourages attacks on the network by making attacks less advantageous for the miner. With private blockchain, they have operators that can edit, override, or delete entries on the blockchain. They have full control over who participates in maintaining the shared ledger, so it's not decentralized. These blockchains act more as databases with underlying cryptography concepts. So they don't fit into either of the proof of work or proof of stake models. Currently, the reward for adding a block to the Bitcoin blockchain is 6.25 Bitcoins, which is about $266,000 as of September 25th. So you might be asking, what's the point of all of this? Well, this verification ensures that when a block is added, that is valid and it creates an immutable ledger. Every block uses the hash of the block that came before it as a way to look back to the first block. This is referred to as the superblock. So this slide just shows a picture that illustrates this concept, that every block is hashed to the ones before and after. So if a block were ever edited, it would sever the chain and make every block that comes after it invalid. Finally, we'd also just like to point out that it's not impossible to edit a block, but it would be extremely difficult to pull off. A bad actor would need 51% of all computing power within the network to recalculate all of the blocks that come after. There is a conservative estimate that states it would take at least $5.5 million to buy the necessary hardware to achieve this, or that it would require the bad actor to simultaneously hack into hundreds of separate mining operations. So next, I'm going to pass it off to Juwir, and she's going to give some company examples.
Thank you, Patricia. And next, I'll talk about the company examples of blockchain. So at these slides, you can see the blockchain has been used for many industries, which includes the bank and the finance, supply chain, healthcare, insurance, energy, real estate, trade, government, IoT, and travel. And I will talk about several companies as examples. So first, I'll talk about Visa within the bank industry. Visa is one of the companies with blockchain technology that did a long way in the industry. Previously, in 2016, they introduced a blockchain platform that would deal with business-to-business payment services. However, it took them time to make the project live. They wanted to cover 90 markets that the business can make payments to by the end of 2019. Visa's research and product teams have developed a new concept to move the conversation forward. They call it Universal Payments Channel, which is UPC. The UPC acts like a hub. It's interconnecting multiple blockchain networks and allowing for secure transfers of digital currencies. And next, I'll talk about the Walmart within the supply chain industry. Walmart has been a blockchain enthusiast for a very long time. In reality, the company is using IBM's supply chain technology, which is called Hyperledger Fabric platform, to back up their supply chain process. The blockchain solution adds transparency to the decentralized food supply ecosystem by digitizing the food supply chain process. By placing a supply chain on the blockchain, it allows making the process more transparent and traceable. Each node on the blockchain represents an entity that has handled the food on the way to the store from the farmers, making it a lot easier and faster to say if one of the farmers has sold an infected product to a specific location. The blockchain also reduced the food supply chain queries from 7 days to 2 seconds. And next, I'll talk about the healthcare industry. I'll use Pfizer, which is a very popular company now, as an example. Pfizer is yet another one of the large companies using blockchain technology. The organization called Clinic Supply Blockchain Working Group, led by Pfizer and Biogen, just completed proof of concept for tracking records and managing the digital inventory of pharmaceutical products. The iOS-based application called KeyChain is designed to fit into the clinic trial supply chain workflow, providing an immutable digital records for inventory and event tracking. It is built on the top of Hyperledger Fabric platform too, and enables users to securely send messages between shippers, customers, and third parties. And next, I'll talk about the SEB Group within the trade industry. SEB is a Swedish financial group for corporate customers, institutions, and private individuals. Its activities comprise mainly banking services, life insurance, and the SEB also owns Eurocard. SEB uses the blockchain to handle all of their regulations and transactions. And there's a new global blockchain platform called Contour for the trade finance transactions went into operations at the beginning of October 2020. SEB has been involved in the development of this initiative and has set up its own production environment for the blockchain. So next, there are 3 questions for the class. The first question is, do you guys have any experience using blockchain, whether it is Bitcoin or other applications? Please tell us in detail. And the second question is, what do you think about the security of blockchain technology? Do you think it is secure enough? And the third question is, do you guys think there are any other industries that could benefit from using the blockchain technology? So that's all for our presentations. Thank you all for listening.